Bismillahirrahmanirrahim. Hello everyone. This is the second tutorial on pushover analysis using STAAD Pro Connect Edition. In the previous example, we will in an overview we discussed on pushover analysis, and then we used a small example. There's a column and pushing the top of the column with a target displacement of 2 inches. Now in this tutorial we will do the pushover analysis from the scratch, which we creating a multi-story steel structure as I mentioned before. So there is no option in the STAAD Pro to perform pushover analysis on a concrete structure. So we will jump to the STAAD Pro and do all these things step by step, including to the post-processing, from the modeling to analyze, loading, and everything. So as example, we can call tutorial 2. Let's give a name, pushover. And you can use metric or you can use any unit you want. So I'm gonna use analytical, and this is also available for physical. You can model physically and bring it to the analytical, and you can perform the pushover analysis. So we will discuss maybe this later, and also there is some tutorial on my YouTube channel. You can see how we can create models from the physical modeler as well. So I'm going to create this one. Save to pushover, yes. And now for the simplicity, I'm going to use wizard. And in the wizard, I come to in case if you forgot to change the unit, you can also change the unit here as well. Let me select frame model. I use bay frame. So the total length is 12 meters, so which has 3 bays, 4 meters each bay, and the height is, let's suppose, 15 meters, which is 5 story, and in a way is 0, which we want to considering a 2D structure. Now want to apply it and close yes, and giving the origin 0, 0. And we have created the model. You can select this node to see. You can come to here, select node, and select this node. You should remember this node number is 21, which we applied the target displacement on this load in this node. Now we go to the properties, and we want to define some section database, some section from the database. Now I wanna give a uniform, just 2 simple section, one for column, one for beam, 12 by section 12 by 100, 12 by 136 is for the beam, for the column, for the beam, and 10 by 100 is for the column. This one. So we have selected 2 sections. You also can use another section as well. So I'm gonna go to the select and selecting beams, and I'm call parallel to X. So I'm going to give it to this W12 to the beam, or assign to the selected beam. So assign, and comes to the 10, and again select to the parallel to Y, and assign to the selected beams. So it is a 3D rendering, and you can see the structure is like this. So we have defined the section and also section beam columns, and we go to the material. So let's suppose that we're using this steel material. You can see the we give just the density, the Young modulus, Poisson ratio, which is elastic behavior. And next I'm gonna go to the support and defining support. I can create a support. I wanna have the base should be fixed here, and I wanna assign to using cursor. You can select node by pressing control, and here is the support. So next is the loading. I can go to the view and showing the front view. Now in the load, before we defining the pushover data, I'm going to define a gravity load called here, and I want to see number, and I can call it gravity load, or let me write it, gravity loads. So I'm going to assign, so I have assign a gravity load, which is including to add self load of the structure and the member loads. Let's suppose we have a 15 kilonewton per meters on the beam. So this self weight is assigned to the view, and the uniform linear load is to the selected beams. Press control, which is you can select multiple beams. So now I'm gonna select to the assign to the selected beams and assign. Now the gravity load is applied. We come back to the pushover definition. We add. Now let me show you here. After you define the gravity load, you should follow these steps. So the first step is 1, which is adding the type of frames, and also in case you ignoring or considering the geometric nonlinearity of X, and also selecting the displacement increment. And the second, you come again and you select the member specification parameter, such as the expected yield strength, and then again to here define the load pattern. First define the load patterns and the requirement of push load steps, and again you defining the spectrum dampings and also the spectrum parameters. And again you have to define the control point, which node you want to define that displacement. You give the direction, you give the target displacement, and you select that node and add and close. And the last one, you have to specify some parameters, such as for the analysis you define the called pushover. Here is actually, it means that you want to assign those specific data to the elements. So we were considering in case if you have multiple yield strengths, so you select each element and do apply this one, and then yes, so then choose the analysis. You choose analysis command and go to perform pushover analysis. So I will do all things step by step in the analysis. So here the first step is that I should select it's a moment frame. In case if you want to consider, so include effect. So let's suppose that we were not considering that in the first step, we're not going to consider the geometric nonlinearity. You have right to do it, but maybe for the comparison analysis you can consider this one. And the second, you come to here, give the incremental load. So this is 15 meters. So let's suppose that you want to push this structure by 5% drift. So if we have 15 meters, then 5% of the 15 meters is 75 centimeters. So I'm gonna give these steps to 0.1, which is almost 1 millimeter, and now I'm gonna call add. So this is the first I have added here, these 3 in the first step. The second step is going to come to here, member and expected yield strength. Here is my I want apply expected yield strength of material of 420 megapascal. So megapascal is Newton per square millimeters, but here the unit is giving kilonewtons per meter. So here is come to the utilize here and using convert unit converter, which is very effective things. So that you want to change from the stress. This is stress. Stress I'm going to using Newton, and it's millimeter, Newton per square millimeter, which means a megapascal. So I'm going to 420 megapascal, and changing to kilonewton per meter, which is exactly to this one. Now you can get this data using this one. Copy and you're putting this one here. Now we're gonna add. In case if you have multiple, then you have to add multiple expected yield strengths for the each elements. So close the converter, and now I can assign to entire elements because I use a single elements material. Next, I come back to the pushover data here, and this time I'm going to define a load pattern. So in the load pattern, just I want to give the step, the number of steps that the program should save for me for the analysis. So I will apply 75 or 750 millimeter. So each millimeter give me one step, or give me 350, called add here. And next we go back to pushover analysis, pushover definition. Here I should define the spectra. We define this one, and we need to define the spectra. Here is the critical damping. You can give multiple critical damping for the spectrum that you want to define here. So let's suppose it's have 5%, and the site class or category is, you can check section 1.6 of the AAC 14. So I'm going to use a class A. So the short period is 1.6, and the 1 second is 1.2. You can get this data from the earthquake hazard map of your own countries, or you can use UBC code or another AAC 7 others. You can get this data. Now we have defined this one, and the last thing, I should define some Hinge properties to the structure. So we have two options. One is FEMA and another is user defined. In case you have the properties of the section, then you should determine this data. You can use AAC 7 and AAC 41 to get these parameters, and also calculate the plastic yield moments. So I let the program to determine for me. I'm just going to select FEMA and I call add. Now the same thing that I should assign this to the specific elements. So I wanna program should calculate all those parameters for the each elements. So I'm gonna call assign to view. Assign to view. Now the Hinge is also defined, and the last thing again comes to this pushover and I call add. Here is called the solution control. In the solution control we have two type of solution control. One is load definition or base shear force, and the second is displacement. So we usually use the displacement and to get the shear, but you also can apply the shear and get the displacement as well. So I'm going to apply this one. So this is 0.75, which we already said, about 5% of the total height. Now in the beginning we have selected that joint was 21, which is equal to the top of this roof. So we call this sign. Now we have defined the entire parameters for the pushover analysis. Now we are ready to perform the analysis, but before that I go to analysis, and it's called command, and it's called pushover analysis. I'm gonna go add this one in case if you want to see some mode shape, some frequency as well. You can come to the messenger command, and you have to give some kind of mode shape. So we do not require in this one because we have defined the direction and also the node. Now we are ready to run the analysis. I'm going to run the analysis. I'm going to save the model, and it start to run. So it take a while to finish. So pushover analysis, nonlinear analysis, and it takes some time to complete when your structure is quite large with so many elements. So you should be patient and take a risk. Now the analysis finished. It took some time. We can see it's about 102 seconds and total time. So there is no warning, and there is 2 error. We ignore those error maybe because when we pushing to almost 1 meter, so the structure seems unstable. So they was giving some errors. I'm going to automatically go to the post processing to see. This is also the response from the gravity loads. You can see the forces, the moment forces, and also some deflections and other things, but we want to see the pushover response. So you come to the layout, and here is called pushover. So we want to see the response on the pushover curve, and here is the pushover curve. In the first about, this is the millimeter joint, almost 158 seems to this location is elastic, and then it's going to plastic, and then collapsed. So it means a few elements, so mostly beam columns will fail, and other few of them is collapsed, and in this means the entire structure is collapsed. So this is the pushover capacity curve. Then you can interpret, see how the structure responds. You can pick up the maximum shear force of the structure, and also the maximum response in this same point, top point, and then you can calculate the structure initial stiffness, and also the displacement, design displacement, and also the maximum capacities. So we also can go back to here and see the data, which is in almost this is the data which we created, gave us about 64 nodes. We required more, but it gave us this on data. You can copy this to Excel sheet and manipulate with other result with other software and see how it is response. We also can go back to the post-processing, or we're gonna go to beam result as well, and from the gravity load we also so we do not have pushover here, and again in the layout We also check the node results, and not just this one, so we can select another node response as well. So you can see here node 15 is almost here. The displacement is in y direction is this much, and in the x direction is this much. Because this is y direction, so as it seems the gravity load effect is very high, and this is first step, and you can select the last step. Let's be for t, step 4t, and you can see the displacement in the x is quite large, so in the y is -2, which is a little bit here, you can see. And you can see some deformation as well. So we're gonna go to 3D rendering, so we cannot see in the post-processing the rendering. So now it's the deformation. It's 5. Let me go to 15. Is no. We can go to here. Yes, here is. So we can see more deformation. So like this you can play with this analysis and interpret the analysis. Okay, this is the end of the tutorial. If you have any question, please put in the comment and I will find time to answer you. See you next time.